where we left off on IVT, intermediate value theorem. Okay. And we had talked briefly about A and B on number 2, just because I kind of wanted you to have something. We'd learned about intermediate value theorem, but I wanted you to have something to reference here. Okay. So this one had asked, on the interval -2 to 5, is there a value of x equals c on the interval from -2 to 5 such that the function equals 1? And again, these purple lines I add afterwards, -2 to 5, is there a place where the function equals 1? And that happens right there, yes? So there is a spot where that happens. So yes, c exists on that interval. Does IVT guarantee a value of c on that interval? And remember, the answer is no here. And one of the big reasons is because the graph is not continuous, right? Whether the value exists or not is irrelevant to intermediate value theorem. Intermediate value theorem just guarantees whether something exists, okay? So if we now look at C, new graph, is there a value x equals c on the interval 1 to 6 such that g of c equals 3?
No.
No.
So what is it?
G of C is always y, right?
Uh-huh. So here's 1 to 6. Does the graph ever equal 3?
Nope.
Nope, because that would be up here, right? So, no. And how do I'm sure I did not just say no.
What?
No.
I even checked my answer with Mario, and he said yes, and that's what I
I
got.
also
And
I
said-
totally understand that, and I'm
I
not sure
thought,
why.
no, it doesn't exist.
No.
I think I was
C
looking at
doesn't exist.
Why
on
is it-
interval 1.
X.
Because there's nothing at
Is
3 from
So-
the left and the right, or 1 to 6.
So first of all, it has to be on the interval of 1 to 6. So we're talking 1 to 6. Nothing over here matters. Nothing over here matters, right?
Right.
And then remember when it says, is there a value x equals c such that g of c equals 3? Such that at the x there is a y value of 3.
Oh.
But where's a y value of 3? Not on the interval from 1 to 6.
So G of C is a y value.
C is the x value, and then what g of c equals is a y value, yes.
I was looking at the X value.
I also was like with the X value.
And what I can say is no, there is no such value on 1 less than or equal to x less than or equal to 6 such that g of c equals 3. Actually, I should say g of x here, shouldn't I? No, I have g of c 3 equals in my notes, so. Okay. And again, the fact that, I guess it doesn't matter. You guys said you were just looking at x values. This over here doesn't matter because it's outside of the interval. So now, does IVT guarantee a value of c on the interval from 1 to 6 such that g of c equals 3?
No.
And considering the value doesn't exist, let's hope that IVT doesn't guarantee one, right? Now, why does it not guarantee one?
Because there's no value in
And it's not.
it. Yeah.
Well, okay, wait, let's address, is continuity the issue?
No.
From 1 to 6?
No.
Gosh darn it. Okay, 1 to 6, the graph is continuous, yes?
Mm-hmm.
What's the issue? Why is it not guaranteed here,
Because there's no value there. It's decreasing.
right? What's the highest value on this interval?
Probably more like 1.5.
What's the lowest value?
And
Negative.
negative infinity.
No.
Positive.
On this interval,
Oh.
the
No,
lowest
negative.
spot, does that make sense?
Yeah.
So right there, it's also, if you recall, and we haven't re-gone over the restrictions here, but it's also based on highest and lowest values. If 3 does not fall in between the highest and lowest value of the endpoints, it's not guaranteed. Okay, now how did I state that in my notes? IVT will not guarantee a value where g of c equals 3 because f of 1 equals 1.5 and f of 6 equals -1, and 3 does not lie between those two values. Okay, so no. IVT does not guarantee, excuse me, a value such that g of c equals 3 because f of 1 equals 1.5 and f of 6 equals negative 1. Okay. And if you wanted to put in extra, because in parentheses I have and 3 does not lie between 1.5 and negative 1. Officially, that doesn't have to be stated, but if you want, you know, kind of some basic words there. Okay. When you're ready, this may require some looking back. We need 3 conditions that are necessary to apply the intermediate value theorem. So I'm looking for 3 conditions that are necessary. Okay. We've already talked a little bit about it today. What's one?
A continuous function on an interval cannot skip values.
Okay. So I'm going to say that f is continuous on the interval, closed interval, a to b. Okay, f has to be continuous on the closed interval and including the endpoints officially. So thus we say closed interval. Okay.
Y values cannot equal A or B on the,
Not,
cannot be the same. Can't be the same A and B.
okay, so where the endpoints, is this what we're talking about, the endpoints?
Mhm.
Okay, so f of a
Cannot equal A.
cannot equal f of b. And remember, the reason your endpoints can't be the same is because that could just be like a straight line then. And then there's, you know, there's no varying in your y values. So f of a cannot equal f of b. And what did we just demonstrate here?
F of A is less than F of B.
Well, where's f of c have to be in relation to f of a and f of b?
It has to lie in between.
It has to be lie between them, right? This goes back to the 3 does not lie between 1.5 and negative 1. Fancy speak for that is, this was g. G of c does not lie between g of a and g of b. Okay, so I've been using f down here, so f of c must be between f of a and f of b. F of c must be between f of a and f of b. Okay. Those are the pieces you're trying to make sure happen. And again, remember the big place this is used is if you're trying to guarantee the existence of zeros. So whether something crosses, you know, like for instance, on this graph that we just looked at here, can we guarantee the existence of a 0 on the interval from 1 to 6?
Yes.
And that we can, because we have one endpoint that's at 1.5, the other endpoint's at negative 1. At some point, it has to cross through the y value of 0. Okay, so that's one of the big places that it is used. Okay, let's look at some examples here. Apply the IVT, if possible, on the interval from 0 to 5 so that f of c equals 1 for the function f of x equals x squared plus x minus 1. Okay. Well, if you think about our 3 points we just talked about on the previous page, what's something we have to check?
We have to make sure that it's continuous.
Okay. Is x squared plus x minus 1 continuous?
Yeah.
Yes.
Yes.
Yes. And this falls into the category, it's a polynomial. It falls into that broad category if it's a polynomial, which is just your x terms added or subtracted, no x's in the denominator. Besides the fact you guys know this as a parabola, but any type polynomial is good. So one thing I can point here or put here is that f, is it f? Yes. F of x is continuous, and in my notes I have written that it is continuous on the reals. That's that fancy R. Okay.
Guys, second grade is hard.
It's the other, and then I don't have written in here, but interesting, you can also say, you don't necessarily have to state this, but since polynomials are continuous everywhere. Okay, there's 1 point. So far, so good. What else?
F is f of a cannot equal f of b.
Okay. F of A cannot equal F of B. So what's that mean in this problem? What are A and B?
The two.
0 and 5.
Okay. So A and B are 0 and 5. So we need to check and see what F of 0 and F of 5 are and make sure that they're not equal to each other, right? So what is F of 0?
-1.
Right? Plug in 0, 0 squared plus 0 minus 1. What is F of 5?
29.
25 plus 5 minus 1, 29. Okay. And they're not equal to each other, correct?
Correct.
So we're good there. And I say I don't have it written up there, but if you wanted to, you could specifically state F of 0 is not equal to F of 5. Okay? And we're pretty much there. What do you know?
That means f is continuous.
Well, it's continuous, and
Oh,
I'll be on the answer.
oopsies. F of c is between
C's gotta be between A and B.
is F of, so in order for IVT to guarantee that F of C equals 1 exists, what has to be true? 1 has to be between
0.
F of 0 and F of 5, which are
-1.
-1 and 29. Is 1 between -1 and 29?
Yes.
That's the easy part, right? Okay, so IVT applies here and is true. There is some value of C such that F of C equals 1 on the interval from 0 to 5. Okay, now, how did I write that out? Then by IVT, there exists a value C where F of C equals 1, since F of C takes on every value between -1 and 29 on the interval 0 to 5. What of that do I want to write? By IVT, there exists, and that's the key, this is an existence theorem, so there exists a value C where F of C equals 1. Since I think what I want to say here, Okay. Since f of x takes on every, my goodness, I can't write, every value from -1 to 29. Oh my goodness. The board is not liking what I'm writing. On the interval, is it 0 to 5? Yes, 0 to 5. Okay, I mean, this is getting some of the fancy lingo. And there is some of that you have to be able to do in calculus. You have to at least be able to understand it. There are times you have to be able to write it. Okay? That's our fancy way, you know, and that's our fancy way for explaining it. But we've got that information up here, yes? We have the -1 and the 29 here. So, you know, we've already stated that they're not equal on the endpoints. We've already stated what those endpoints are. So all of that kind of works together there. Okay. Ready to try B now?
Yep.
Speaking of zeros, which I mentioned earlier, use the intermediate value theorem to show that f of x has a 0 in the interval 0 to 1. What do we mean 0?
Like somewhere that it crosses the x.
Okay. And so if that's the case, what is this trying to say? F of c would have to equal
0.
0. So if they're asking about a 0, that's an x-intercept, right? X-intercepts carry a y value of 0. So when they say that, you're trying to prove that f of c equals 0. Okay. Well, what do you think about continuous?
Yes.
Because
It's a
It's a
Polynomial.
it's a polynomial, right? Enough said. So f of x is continuous. I'm just going to say, since it is a polynomial. What else do you want to check?
f of a and f of b.
Okay, f of a and f of b, which in this case means I'm checking
0.
f of 0, which is -1, and f of 1, which is
1.
That's 10.
like you guys just throwing out numbers that was not in my head, but then I lost track
Oh,
of
it
what
is
was in
2.
my head. 1, if I'm plugging in 1, it becomes 1 plus 2, which is 3, minus 1, which is 2.
yes.
Okay, and what do we know about these endpoints?
Not equally just.
F of 0 is not equal to f of 1, so that speaks well that the endpoints are not equal to each other. Now what?
0 is between -1 and 2.
Okay. Now, so similar to the, you know, basically 0 falls in between those points of -1 and 2. Because they're asking about zeros, how I have this written is that since f of 0 is less than 0, aka negative, right? And f of 0 is greater than 0, aka positive, then a 0, there exists a value such that f of c equals 0. Okay? Again, lots of different ways to write this, but since f of 0, my parenthesis got away from me, is less than 0, and f of 1 is greater than 0, there exists a value x equals c such that I want to say C is 0? Is that what I want to say here? There exists a value such that, such that f of C equals 0. I had a moment. Why did I write that out like that?
I know, I was just wondering.
I know, I was just saying that.
Don't ask.
it.
No, you don't. Why? I got done with that. I'm like, why? Why?
I
But it's
didn't
going on
notice you.
today. Today's just a rough
I
day,
didn't
and
notice
that's
you put
okay.
equals.
It has been a rough.
I wrote the words equals and 0. Now, does it matter?
No.
Could you do that?
Yes.
Yes.
Usually whenever I'm listening to you talk and I'm writing, then I'll do
Yeah.
that, but then I'm like, crap, and I'll go back and erase
Yeah.
it because I don't want it like that.
Okay. And then, okay, on the interval 0 less than or equal to x less than or equal to 1, and I need to state, I didn't start with this, so by IVT. Okay? If you're claiming IVT, you need to state that at some point, whether it be in the beginning, the end, the middle. Oh, Lordy.
He doesn't have time for it. It's been a rough day.
Luckily, we only have 4 more
As
problems.
Ross County said, it's been an STD, a sort of tough day.
All right.
Okay.
Okay.
I'm ready for problem 5.
Anyways,
Sort of tough day.
Moving on.
A car travels on a straight track. During the time interval 0 to 60 seconds, the car's velocity, measured in feet per second, is a continuous function. The table shows below selected values of the function. So, there's 2 questions. First question, for values from 0 to 60, must there be a time t when v of t equals -5? And B is just justify. So really, I feel like we're doing the same thing that we were last time, essentially. But okay, what do you think? Must there be a time when v of t equals -5 on the interval 0 to 60?
Mhm.
Yes?
Because
Because there are,
well, -20.
there's values above -10 and below -5, right? Above -5 and below -5. Now, in all honesty, I was looking right here, you know.
Yeah, I forgot.
Okay, so let's do the justify. What do we know?
It is continuous.
How do we know it's continuous?
It states it.
Okay, that's exactly what I need to hear. Right there, guys. Is this continuous?
Yes.
yes, it tells us.
Okay. It states it's continuous. Okay. That is something they do. Because otherwise, can we claim IVT here? No, because we don't know if it's continuous. But this claims it's continuous. So, right there, what are we calling this? V of t? We can say V of t is continuous. Okay? Now, trying to remember, what about endpoints here?
-30 and 10.
Yeah.
Well, and here's the deal.
Wait, it's
So-
0 and 60.
Well,
Yeah.
I think we can do this a couple of different ways, in all honesty. Okay? Could we use 0 to 60? Does that work?
Yes.
Yes. Now, in my notes narrowed it down, and I don't see any reason you couldn't do it either way. What's the other option we could look at here?
35, 60.
Don't even have to go 35 to 60. You can just look at 35 to 50, because what happens here, that's where you get the -5, isn't it? Okay? I don't think it would matter in a testing situation. Whether you use the 0 and the 60, because that would be -10, 10, and that happens as there as well, right? Okay, since it's continuous. So either way, examine those endpoints. So if I use V of 35 is equal to negative 10 and v of 50 is equal to 0. So then right there we know that v of 35 is not equal to v of 50. So third piece, is it guaranteed? Yeah, because negative 5 falls between negative 10 and 0, yes? Okay, so by IVT, there is a time t guaranteed such that v of t equals negative 5 on the interval. So be on the interval where t is between 35 and 50. And I'm going to say since negative 10 is less than negative 5 is less than 0. And those were the endpoints there.
I like this lesson. I understand it.
Cool.
Okay. Ready?
I'm waiting for
The
this
worst
midterm.
part
I'm like,
is
let's
No,
get
no,
to
no,
this
like,
midterm.
let's
I
get
gotta
to
go
the
time.
The worst part is writing out the by IVT stuff.
But again, and I know it gets repetitive, but if you don't ever practice it, it's really rough come an AP setting. Whereas if we practice it, at least you'll have some idea for, okay, how to get in that groove. Okay, let g be a continuous function. Selected values of y equals g of x are given in the table below. For which value of k will the equation g of x equals 3/4 have at least two solutions on the closed interval 2 to 8?
Nice.
I'd probably skip this one in the AP test, but
Yeah, same.
Okay,
Like,
So-
not for me.
Can it? 'Cause it's the-
first of all, it starts off stating that this is a continuous function right there. So we can't apply IVT. You know, like once you get in reading into it enough, you can't apply IVT. When you think about that at the time, who knows? Okay. For which value of k? So we're trying to, what you have to remember here, because there's a lot going on in this question, isn't there? These are all k values. Okay, so those are k values that we're trying to pick here. Will the equation g of x equals 3/4 have at least two solutions on the closed interval 2 to 8? Okay. We got it? I know. What does it mean? I'm trying to decide where I want to start, you guys. Okay. What does it mean to have at least two solutions on this interval? What do we mean solutions? What do solutions look like on a graph?
Zero, right?
Zeros, as in where the graph crosses the x-axis, yes? And we're trying to specifically find this lovely little k value, right? So we want there to be two solutions on the interval from 2 to 8. Well, the problem is right now, this is continuous, we know, but as you look on the interval from 2 to 8, what do you notice about these y values?
got bigger and then they dropped.
Yeah. But they're all,
Hold on. Can I go to the bathroom real quick? I'll sign out when I come back. I just don't feel very good.
Okay, yeah. Okay. They're all positives, yes? What's going to be the case if they want us to have two solutions here? What are they going to have to cross?
The x-axis.
The x-axis, yes? Okay, so if we have, I'm trying to think what I did here. Like if you look at that point is 3, 4. I'm just making an arbitrary point. This point over here is 5, 5. Okay, yeah, we had, I just went from there to there to look at. We have two other points out there, 2, 3, and 8, 2. But what's the graph going to have to do if there's two solutions?
Dip down and go back up.
It's going to have to dip down and go back up. We don't know exactly what it's doing, but it's going to have to dip down and go back up, isn't it? To be able to have two solutions. Valid point here?
Yeah.
Okay. Now, what did it ask? This is where I have to get it all back in my head, right? For which value of k will the equation g of x equals 3/4 have at least two solutions on the closed interval? So we're looking for when g equals 3/4 has two solutions. What? Okay. Why?
I don't know. Just because it's just g of 3/4 squared.
Okay, not the right reasoning.
No. Just
It's a good guess.
because. Well, because it has to touch twice, right?
Mm-hmm.
That's the squared part. That's probably wrong, but that's what my brain went.
I'm trying to figure. I'm not
Because
Oh, my brain's struggling here for a moment with.
why it felt that way?
Do I want to say yes to that, or do I want to say no to that?
It has to dip down and go back up.
Right. I was looking at it for another reason. So we want the equation. So I guess I drew this thinking this is the x-axis, but really this is 3/4, right?
Mm-hmm.
We want the solution, the equation 3/4 to have two solutions. So we want to cross through there,
That would be it.
which means my k value, it's not going to have to be negative, which is what I was originally leading you to. It's going to have to be, well, it has to be a positive because that's my only option here, but it has to be a number that is what's going to take me below the line 3/4. It's going to have to be a number lower than 3/4. That's the direction I was going. Sorry, there's a gnat flying around up
I
here.
don't know what that is then.
Okay. Is 1 less than 3/4?
No.
Is 3/4 less than 3/4?
No.
I don't know what that is. Is 3/2 less than 3/4?
Yeah, they're not.
No.
No, because that's 1.5. So 9/16.
It's not 3/4 though.
No.
It's 3/4 squared, but it's not 3/4.
3/4 would be 9/12.
9/16. So if we're talking 16ths, what, 12/16 would be 3/4?
Yeah.
Right?
Yeah.
So this is the one that is, if we're looking for a value that's going to get us below here, we need to know where k is less than 3/4. And this is the only value where k is, that would make k less than 3/4. Okay? Because keep in mind, what's difficult about this is, do they tell us what the equation, what g of x is?
No.
No. They don't tell us what g of x is, which is why you have to really think it through. Now, my mistake is I overlooked that two solutions for this right here which means 2 solutions means it crosses through there twice, so we have to get it below that. That was my misleading. My apologies. We'll go with the Monday excuse. I don't know.
Monday excuse sounds really good right now.
That's definitely not right.
Okay. Did I get you there somewhat?
Yeah.
Kind of. Okay. Okay. Let's look at the next one. For this lovely, fun piecewise function. Calculus loves piecewise functions if you haven't started to realize that. Okay.
I love them too. So,
Find f of 5 and f of 10. Does IVT guarantee a y value on the interval from 5 to 10 such that f of k is between f of 5 and f of 10? So, with that in mind, it starts off saying find f of 5 and f of 10. Shall we do that?
yes.
What about f of 5?
Equals 4.
Agreed?
Hold on, how do you figure that out? Oh wait. Just kidding. I know how to do that.
Since it says when x equals 5, you have to use the top piece, right?
Mm-hmm.
We're plugging 5 in. 5 minus 3 is 2, and 2 squared is 4. Yes? Okay. It also asked us to find f of 10, if I recall. What about f of 10?
Equals 6.
Agreed? Yeah. Because when x is anything from 5 to 10, it says it's just equal to 6. So f of 10 equals 6. Okay. Does IVT guarantee a y value on the interval from 5 to 10 such that it is between f of 5 and f of 10? In order to be able to talk about IVT, what do we have to be able to talk about?
Continuation.
Okay.
If it's continuous.
Is it continuous?
How is it now?
No.
Nope.
Well, no, because it's piecewise.
Yeah.
Piecewise can still be continuous.
Well, a piece of
And they.
But all the pieces do sometimes join. How do we show if this piecewise is continuous or not?
the endpoints of each of the pieces.
Well, so from 5 to 10, it equals 6. So is it continuous there?
No.
It's continuous.
It's just a flat line.
It's a flat line.
It's dead.
What about when this is 5?
It's a traveler.
It's equal to 4.
Oh.
Because there's only one value that this exists at, yes? If there are multiple values, I'd go with it's a parabola, but this only exists at one value. So why they even put an equation here is beyond me. Okay, but remember when we're talking calculus and we're trying to officially say if something is continuous, can we use limits?
Yeah.
Okay, and the question we have here is at 5, right? So let's talk about the limit from as x approaches 5 from the left, I guess I want to say. Of f of x. And if we're approaching from, oh, I guess I didn't, what did I do? I didn't, oh, this doesn't exist from the left, does it? So I can't really use from the left. Okay, let's make that from the right. Let's start with from the right.
Equals 6.
From the right equals 6, yes? Because as you go from 10, work your way down, it equals 6. Now, what about the limit? Okay. The limit is going to be the approach is 6. What is the graph equal at that value? That's where I'm going. F of 5, we already said equals 4. What has to be true for continuity?
They have to equal.
The limit from the left has to equal the limit from the right, has to equal the value at the point. And right there, what just failed?
The value.
Yeah, we just found that the limit as x approaches 5 from the right of f of x does not equal f of 5. So, does IVT guarantee this value?
No,
No, because
it's not continuous.
it's not continuous. IVT does not apply. Okay? So, I'm going to say IVT does not apply since f of x is not continuous on the closed interval from 5 to 10. And if you want to go one more farther, you can. There is no guarantee for x equals k where f of 5 is less than f of k is less than f of 10. Hopefully you're starting to notice this continuity thing is a whole big deal, isn't it? Okay, there's a lot to do with continuity here. Okay. One more one when you're ready. See if we can wrap our brains around it. This is taking longer than. See, I should have known. I should have never said anything. Okay. The functions f and g are continuous for all real numbers. The table below gives the values of the functions at selected values of x. The function h is given by h of x is g of f of x plus 2.
Oh, yeah.
Explain why there must be a value w
No, thank you.
for w to be between 1 and 6 such that h of w equals 0. Okay.
It's continuous.
Valid point?
Yep.
Now, what is continuous?
Functions are
F and
graphs.
G.
F and G are continuous. Now, by definition, H is defined as this, yes?
Mm-hmm.
And so by definition, if F and G are continuous,
H is continuous.
then H is continuous. So that is one thing I can state, is that F and G are continuous. So H of x is also continuous. And officially, I'm going to say on 1 to 6. Oops. I should be using the closed interval, though. Okay. Now, we're trying to figure out a value for h, yes?
Mm-hmm.
Okay. Really, even though they give us f and g information, this is all about h. So, thus we had to say that h is continuous. What else do we need to do?
If A and B are equal to each other.
Okay. H of A and H of B, which are going to be H of
1 and H of 6.
H of 1 and H of 6, yes? Okay, so we got to do some math. How do we find H of 1?
Plug in.
It's G.
F of x
It's
is
gone.
2.
Okay, so we're doing G of F of 1
And G
plus 2.
is negative 12.
Huh?
So then it would be
Negative
negative 1.
If you ask me.
Start on the inside.
Absolutely going.
What's F of 1?
Good job, Sophie.
2.
Thanks.
So now this becomes G of
2.
2 plus 2. What's G of 2?
Negative.
Negative 12.
Oh, I'm stupid. Hey.
That was
Negative 12
Alright.
plus 2, which is negative 10. So agreed that h of 1 is negative 10. Repeat the process. Should go a little smoother this time. H of 6 means I'm doing G of F of 6 plus 2.
30.
F of 6?
30. Give it a second, Doug.
F of 6?
8.
8.
I got 7, but I was looking at the wrong box.
So that now becomes G of 8 plus 2. G of 8. 28
Plus 2.
plus 2.
30.
30.
Okay.
Are we all there?
Yes.
Yes.
I don't care how quickly or how long it took you to get there. Are you there? That's my caring.
Or
Okay. Now, and what do we notice here? These two are not equal to each other, which is a good thing, yes?
Yes.
Okay. So, explain why there must be a value on the interval from 1 to 6 that it equals 0.
All of the above.
Because it's in between.
Okay. It's continuous. The endpoints aren't equal to each other, and
0
It's in
is
between.
yeah, 0 is between h of 1 and h of 6, isn't it?
I hope so.
Okay. And this is all because of
IVT.
our friend IVT. Okay, by IVT, there exists a value. Now, I'm not going to say x equals c this time. I'm going to see x equals w because that's what they gave me in the problem. So there exists a value w where h of w equals 0 since h of 1 is less than 0, which is less than h of 6. And that is on the interval
One
1
six.
to 6. So 1 less than w less than 6.
All right.
Okay. There you go.
Yeah.